All right, let's dive right in. I want you to imagine something for a second. What if you could build a huge, fully working piece of software, but no human ever wrote a single line of code? Sounds like something out of a movie, right? Well, a team at OpenAI actually did it. They started with a completely blank slate, an empty code repository, and just let an AI agent called Codex do all the programming. Today, we're going to break down exactly how they pulled this off and what it could mean for, well, everything. This was their one big rule, the core constraint that just changed the entire game. And when I say no human code, I mean it. From the app's logic to the tests, even the documentation, every single letter was typed out by the AI. Now, this wasn't some little side project. This was a full-blown product, for actual users, built on a philosophy that's just completely different from how we normally do things.
So what did they get for following that one simple rule? This. 1 million lines of code. 1 million. The AI built the entire thing, from the user interface you'd click on all the way to the servers in the back. That number, that's just staggering for any project, let alone one built completely by an AI.
And if you think that's wild, here's the real kicker. That entire million-line code base, it was built from a totally empty folder in just 5 months. The team figures that's about 10 times faster than if humans had done it the old-fashioned way. The speed they were moving at it's just almost impossible to wrap your head around. So all that speed translates into some pretty mind-blowing daily numbers. The team was averaging 3.5 pull requests. Think of those as new batches of code being submitted, per engineer every single day. Now, to put that into perspective, a typical engineer might do one every couple of days. So we're talking something like 7 times more productive. Suddenly, the bottleneck wasn't about how fast a human can type code anymore. It was all about how fast they could think and give directions.
Which, of course, brings us to the million-dollar question, right? It's one thing to see these incredible results, but how in the world did they actually pull it off? How do you guide an AI to build something so massive without it just creating a huge, tangled mess? Well, the answer really forces us to rethink what engineering even is.
Okay, so the first big change? They had to completely redefine what it means to be an engineer. If the AI is doing all the work, the human's job has to change, right? It's got to get way more strategic. And it all boiled down to this one simple idea. Humans steer, agents execute. See, the engineers weren't writing code anymore, but they were more important than ever. Their job completely shifted. Instead of writing functions and loops, they were designing the playground for the AI, setting the rules of the game, and just making the high-level goals crystal clear. They basically became architects and conductors, not just the construction crew.
Here's a good way to think about the difference. A traditional engineer, they're laser-focused on implementation, the how. But this new agent-first engineer, they focus on intent. Their main job is to design the perfect environment for the agent to succeed, to make the goals super clear, and to build feedback systems so the agent can learn and fix its own mistakes. It's a huge shift, from being in the trenches to being the general on the hill.
Now, of course, you can't just tell an AI, hey, build me an app, and then go grab a coffee. It's not that simple. The team hit a huge roadblock pretty quickly. How do you give an agent enough context to actually be helpful on a big, complicated project without just completely overwhelming it with information? And yeah, they really hit a wall. Think about it. An AI model, by itself, knows nothing about your project. It doesn't know the history, the goals, the way you like to build things, nothing. And with that context, it's just going to start making stuff up or missing really important rules or just getting totally lost. So the team had to figure out, how do we teach this thing to, read the room? Their first try was exactly what you'd probably think of. They tried to create this giant instruction manual, just one massive file with everything the agent could possibly need to know. And it was a total disaster. Why? Well, for one, a manual like that gets old and outdated instantly. They say it rots. It's also way too dense. The AI can't tell what's important. You can't really check if it's being followed. And maybe worst of all, it forces the agent to waste all its brain power on general rules instead of the actual problem it's trying to solve right now. So they came up with this much smarter, much more elegant solution. They call it progressive disclosure. And the idea behind it is so simple, but so powerful. Give the agent a map, not an encyclopedia. So instead of that one monster file, they built this whole organized system of documents right inside the project itself. The agent starts with a simple, high-level map, and that map points it to more detailed info only when it's needed. It's brilliant, right? It only gets the exact context it needs right at the moment it needs it.
All right, so the agent has context now, it's not lost. But remember how fast this thing is moving? How do you keep the whole project from turning into a giant, tangled mess of what we call spaghetti code? This is where having a strong architecture isn't just a nice to have, it's absolutely essential.
The key idea was this: focus on enforcing the big, non-negotiable rules, the things that absolutely cannot be broken, but don't micromanage how the agent does it. So, for example, they'd make a rule that says all data must be validated right when it enters the system, but they didn't care which tool or library the AI used to do that validation. This gave the agent a ton of freedom, but inside a really safe, predictable sandbox.
And this is the actual structure they built to enforce those rules. They created this super strict one-way street for how different parts of the code could talk to each other. Basically, a piece of the system could only depend on something that came before it in this chain. It could never look backwards. And this wasn't just a guideline written down somewhere, it was physically enforced by automated checks. This is what stops the agent from making a chaotic mess and keeps the whole thing clean and organized, even when it gets huge.
But what about just messiness over time, Entropy. Even the best systems can get a little messy as they grow. To fight that, they built something super cool they call code garbage collection. It's basically an army of little AI bots that are constantly scanning the code, looking for anything that breaks their golden principles. Like, say, if the agent wrote a custom script when it should have used a shared tool. It finds this AI residue, as they call it, and automatically opens up a request to fix it. It's like turning human good taste into an automated, never-sleeping janitor for your code.
So, let's take a step back. You've totally redefined the role of the engineer, you've solved the context problem, and you've built these rock-solid architectural guardrails. What's the payoff for all that work? Well, you get a level of automation that is, honestly, it's just incredible. Just listen to what the agent can do, completely by itself at this point. You give it a bug report. It then goes and reproduces the bug, and even records a video of a happening. Then it writes the code to fix it. Then it verifies its own fix and records a second video proving the bug is gone. Then it opens a pull request with the fix, and finally, it merges that change into the main code base. This whole cycle can happen from start to finish while the entire human team is at home sleeping. So, when you put it all together, this whole experiment points to a future where writing the actual code isn't the hard part of making software anymore. The real challenge, the new frontier for human creativity, is going to be designing the systems around the AI. The environments they work in, the feedback loops they learn from, and the control systems that we use to guide them where we want them to go.
And that leaves us with a pretty profound question, doesn't it? For decades, the one thing that has always limited how fast we can build software has been how fast humans can type and think. If you just remove that limit, what becomes possible? What happens when the main bottleneck isn't our speed, but our imagination? When the only thing holding us back is how well we can describe what it is we want to build, what kind of future are we going to create?